Basically, as we can see, section 1 and section 2 are not symmetrical about the neutral axis. So we are going to use this animal we are calling the parallel axis theorem. Parallel axis theorem, which states that the moments of inertia of a section about a given axis is given by the moments of inertia of the section about its central axis. You add the area of the section and square the distance of the center of the gravity, the center of gravity of the section from the neutral axis. H, that is H, actually. As we are going to see, for example, taking section 1, section 1, the moments of inertia of the section about its neutral axis. It's a rectangular section. As we said earlier, the moments of inertia of a rectangular section is given by the formula BH cubed. BH cubed over 12, or BD cubed over 12. As we can see, for example, the section number 1, that is this section, BD cubed over 12, that is its moments of inertia about its central axis. Its central axis is actually, its central axis is about somewhere through its neutral axis. BD cubed, that is 100. You multiply by 20 cubed. As you can see, the thickness is actually 20. You divide by 12. And then plus AH cubed. Now, its area is actually 100 times 20. That one we don't have doubt. But coming to the distance of the center of gravity from the neutral axis of the section, as we can see that the center of gravity of section 1 is actually at a distance 10 from the top of the top of the section, and in that case, it's a distance 10 from the top of the section, and the distance from the neutral axis to the top of the section is actually 32.33, as we had seen earlier. So it means that the distance from the center of gravity of section 1, that is 10 millimeters, to the center of gravity of the section, which is at 32.23 millimeters from the top of the section, will be given by 32.23. You subtract 10. And you square that. That will give you now the moments of inertia of section 1 about the neutral axis of the section. That is 10,055,012 millimeters raised to power 4. As we said earlier, the units for moments of inertia is in millimeters raised to power 4. And for section 2, BD cubed over 12, its base is 20, its thickness is actually 80. You divide that is 80 cubed divided by 12. And now going to the other part, that is AH cubed. AH cubed, that is 80 times 20, that's its area. And the distance of the center of gravity of the section 2 from the neutral axis will be given by, as we can see from the section 2, that the center of gravity of the section is in between the distance 80 millimeters. It's at the middle of 80 millimeters. That is 40 millimeters from the bottom. And the distance from the bottom of the neutral axis is at a point 67.77 millimeters. So that means that our H will be given by 67.77. You subtract 40. There is actually 40. You subtract 40, giving us the moments of inertia of the section about the neutral axis being 2,087,209.9 millimeters raised to power 4. And as we had said earlier, the moments of inertia of the section will be given by the summation of moments of inertia of rectangle 1 and rectangle 2. That is the answer that we have here. That is 3,142,222 millimeters raised to power 4 as the units. Basically, as we had seen earlier, T sections, I sections are used in particular places like maybe structural works, machine frames, but for T sections, they are basically, if you look at most concrete works, you can find them there. That is reinforced concrete works. They can also be found in things like machine frames too. For today, we are going to reach there for our lesson. I hope it has been a helpful lesson. Thank you, and sure you're keeping safe.